Okay, so welcome to this video. I'm going to call it More Trigonometric Derivatives, Part 1. So I'm going to look at an example of the product rule and the quotient rule. So this example here, y equals 2 sine x cos x, and this is a product rule because you have a function of x times another function of x. Actually, in this case, we'll say the first function is 2 sine x. So I'm going to take derivative of that. That's going to be 2 cos x. So 3 derivative is going to be cos x. So derivative of cos x is going to be minus sine x. And when I go my derivative, 1 times 4, I'm just going to write this out. I'm going to use brackets here and then explain why in a second. Plus 2 cos x times cos x. Now the reason why I want to use brackets, because if you look here, sine x times sine x, the 2 can just multiply with the minus 1. It's going to be minus 2. But sine x times sine x, I'm going to write this down here. That's the same as x times x, where you got the same base and you add the exponents. So in this case, sine x times sine x is going to be sine squared x, being that your base is sine, and you're adding the two exponents, 1 and 1. And then likewise over here, you got cos x times cos x. So again, you got the 2 times the 1 in front. Cos x times cos x is cos squared x. And if you wanted to, you could factor out that 2. And if it's bothering you that that negative is first, you could rewrite it like this. But that would be an example of the product rule with the sine and cos derivatives. So over here, let's see, I'm going to draw, I don't want to lose that, so I'm just going to draw a little border. This one's going to be an example of the quotient rule, y equals cos 2x times x. So 1 will be cos 2x, derivative of that. It's going to be minus 2 sine 2x. And again, you can consult a prior video where I go through the derivative of cos and sine. 3 is x, and 4 derivative is 1. So remember, quotient rule is 2 times 3 minus 1 times 4 over 3 squared. So minus 2 sine 2x times x. Now we're going to be careful. That's going to come out to minus 2x sine 2x. We do not want to disturb that sine 2x function. And cos 2x times 1. And we are subtracting there. That's minus cos 2x all over. Get a straighter line there. 3 squared, in this case, would be x squared. And if we wanted to, we could factor out the negative. In fact, I think we should. Now, it would be up to your teacher or your professor how far they want you to go, if they want you to apply trig identities. The only one that I really like to apply is when you have sine squared x plus cos squared x equals 1. But we don't have that as a situation here, but in a couple examples in my next video, we will come across that. So stay tuned to